Welcome back, everybody. This is Joe. Tonight we're gonna go over how to build a cell pack, depending on what voltage you want and the capacity of your batteries, what it will equal to once you construct it. We're gonna go over just basics first, and then we'll go over, for our example, what we're gonna try and do at our house. So first off, I'm just going to use the dry erase board and just draw some stuff out to show you the principles of how a cell pack design goes. So first off, we're just going to draw up two different ways of configuring cell packs. Just like any other circuit, we're going to do, of course, parallel and series, and then a combination of the two to create the cell pack that we want. So here we got parallel, and then we have our series packs over here. All right, so this is series. All right, so we got two different cell configurations here. We got parallel. Basically, parallel is where all of the positive leads of each battery are all interconnected to each other to create one main positive, and then all of the negatives are all connected together to create one main negative. Series. You're going to have one main positive, one main negative, but all of the cells inside the pack are going to be connected positive to negative. So in a parallel series or a parallel configuration, we have a couple of principles that apply. So in the parallel configuration, your voltage is going to stay the same throughout the pack. So if this battery is 4 volts, this battery is 4 volts, and this battery is 4 volts, your entire pack will be 4 volts. Your voltage will stay the same across the pack. And your capacity or amperage will change, or will go up. So if this battery is 2,000 milliamp hours, this battery is 2,000, and this battery is 2,000, you're going to add up, meaning that pack would be like 6,000 milliamp hours. Okay, so capacity goes up. Okay, and then in a series circuit or series configuration, it's going to be the exact opposite. So your voltage is actually going to add up. So if this is a 4 volt, this would be a 12 volt battery. So voltage goes up, and it's exactly the opposite. Your amperage or capacity is going to stay the same. Meaning, if these are all 2,000, this whole pack is 2,000. Okay, so let's just say that, let's just break this down a little bit better. So, like as I was saying, your voltage stays the same. So say that these are 18650s, their nominal voltage is 3.7 volts, and this would then add up to it'd be 3.7 volts across the pack. So 3.7 volts, and we're going to stick with that 2,000 milliamp hours because that's a pretty good average. So we're going to add up our milliamp hour ratings, and it's going to be 6,000 milliamp hours, right? And then this one's going to be, we said voltage adds up, so this would be 3.7, 3.7, 3.7, which would add up to 11.1 volts across it, and capacity stays the same, so it would end up being 2,000 milliamp hours. Hope that makes sense. Hey, sorry guys, I got into off onto a tangent here, and I had to cut a little bit of this first part of this video, but I got back on on topic, and here we go. All right, so we're going to merge these two types of configurations together for a series parallel configuration. So we're just going to use what we have here, and we're just basically, it's going to look like we're going to combine the two together, which we kind of are. So what we're going to try and get here is a 3S 3P pack, which will be a total of 9 cells, but it's basically just going to be like this. Sorry about my bad drawing. Okay, so we got 9 cells. All right, and we're going to go all the way across, connect. I'm not going to draw in the positives or negatives. You kind of get the point here. But basically it's like this, okay? So you're going to have 3 parallel circuits, or 3 parallel configurations with 3 cells in each one. So each branch here is going to be its own circuit. So each one of these is going to be 11 volts, because 11.1 volts, because it's its own series circuit. And then each of these is also going to be it's also going to be 2,000 milliamp hours each, meaning across the 3, it's going to be 6,000 milliamp hours, meaning this pack right here is going to be nominally 11.1 volts and 6,000 milliamp hours, because you combine the two together. So you get the max milliamp hours from your parallel circuit and your max voltage from your series circuits. Does that make sense? Yes? Okay. All right. So given this information, now we can go through and we can figure out what we want for our home. Okay? Well, I'm going to erase all this and we're going to move into that. All right, so now we're going to start at designing the pack that we want to build for our house. So I have found out from our electric bill that it's probably quite a bit, but we live in Texas, but we use approximately about 30 kilowatt hours a day in summer. And so what we want to do eventually when we move into our new home is we want to have an off-grid system with battery backup. What we have figured out is that we want right around 100 kilowatt hours of power for reserve. It's quite a bit, but it's worth having that with a solar setup so that in case you get, say, like a week of rainy weather or whatever, you have some backup where you, since you're not producing as much solar, you have some power in reserve. So we're going to start out with that. So we're going to start out with 100 kilowatt hours. And we're going to figure out what size of a pack we would need, what size of a battery system we would need to make up that system. So what we need to do is we need to find out what we're going to use for our battery voltage wise. I've already done my research, and a 48 volt system is about right for what we need, because 48 volts, you don't need as big of cables. You don't need it's just an easier system to do. So we're going to do a 48 volt or 14S battery system, which is nominally actually 58.8 volts. So what we're going to need to do to figure out what we are going to make, we're going to have to divide 100 kilowatt hours divided by 48.8. Let me do that really quick. 100,000 divided by 58.8. So that gives us 1,700 amp hours. That's the capacity that we need from our batteries. We've already figured out that this is going to be a 14S pack or 14S system, meaning 14 cells in series. Now we need to figure out how big our packs are going to be. If we just use just a rough average of cells, most cells, I guess, are going to be around 2,000 milliamp hours. So we need to take our 1,700 amp hours and divide that by 2,000 milliamp hours. So really, we're just dividing that by 2, and because 2,000 milliamp hours is actually 2 amp hours, so divide 1,700 by 2, which would be 850 P, meaning 850 cells in parallel. 850 P. So that's the size of the system we need. Now that is gigantic, and we would never be able to make that. So we need to actually shrink that down into a more usable size. So instead of 14S 850p, we need to make that a little bit smaller. So what we would have to do is make sections of this pack that are paralleled again. So what we're going to try to do, let's see if we can make this into, let's just divide this by 10. So let's take and make a 10p 14S 85p, meaning there's 10 sections of my battery system, right? All right, and each of these sections, you're going to have 14 cells, or 14 series circuits in each of these. And each of those series is going to be 85 cells. Now that may work. That's a whole lot of work. That's a lot of power, or that's a lot of battery packs to make. That's 140 battery packs. If you multiply 10 sections by 14 each, that's 140 battery packs. So maybe we don't want to do 10p. Maybe we want to divide that in half. Let's do this. Let's do, instead of 10p and 85p, let's do 5p. What was that? 170? Yeah, 170p. So that makes it a little easier. So there's 5 sections of the battery backup system. Each section has 14 battery packs in series, and each battery pack within that pack has 170 cells in each one. That's a little bit more, or a little bit easier to make. That's going to make 70 battery packs across the system instead of 140. 170 is not that hard to make a pack. Be a little easier than making 70 or 140 packs. So I think that's what we're going to go with. So let's do the math. Let's go back and double check, make sure our math is right. So if we're doing this, we're going to equal up to, let's see, what's 5 times 14 times 170. So we're going to have 1,190 cells. No, I'm sorry, that's not right. That's 11,900 cells. That's 12,000 batteries.
That's a lot of batteries.
as you could hear my wife, I'm sure, say, it's a lot of batteries. All right, so again, guys, I got onto kind of a tangent, but we're going to cut it off here, and we'll do another video in a few days. If you like the video, you know, hit that thumbs up thing, you know, whatever. Anyway, so thanks for watching my video, and I'll see y'all next time.